I'm going to review 10 different FRQs from past AP Calculus exams. My name's Miguel, also known as the Vegan Math Guy, and I want to help you get the best possible grade on your AP exam. I found 10 different questions that frequently pop up, and knowing them is really going to elevate your game. I've linked the PDF in the description below so that you can download it, print it out, and follow along with me. But before we start, I really appreciate if you give this video a thumbs up, go ahead and subscribe, follow me on Instagram or TikTok so that I can continue posting more math content for people like you to enjoy. So if you're ready, let's get started.
Good morning. It is currently 5:50 in the morning. Woke up, I got my coffee, and I'm ready to review all these problems for you. So again, just a quick reminder, I have posted these in a Google Drive. It's in the description below, so please feel free to download this and work along with me. Okay, so let me just go ahead and let's go ahead and get started. I know that this is a typical problem that they love to give when it comes to area, and usually it's pretty simple. They give you the region of a specific shape between two graphs, and you have to identify which graph is going to be on the top, which one's going to be on the bottom. If they don't specify, and if we're not allowed to use a calculator in this case, just look at the graphs. Look at F. F is a quadratic where 2 is positive, so that means that the function needs to be pointing upward. So we can kind of see that that's going to be the function on the bottom, and that will make g of x the function on top. So let's go ahead and solve part A. Part A is asking you to find the area of the region R, so that is the area between the two curves. Well, we kind of already know our parameters. They intersect at 0, intersect at 2. If we didn't know that, we would just plug these functions equal to each other, but it's pretty safe to say that this is going to be 0 to 2 because we cannot use a calculator in this section. So for part A, we're going to have the integral from 0 to 2 of the function of the top, which is 4 cosine of 1/4 pi x, minus the function on the bottom, 2x squared minus 6x plus 4 dx. Again, this is not a calculator portion, so we are going to have to use our actual methods of integration. So we're going to have to separate these into two different integrals, 2x squared minus 6x plus 4 dx. Got to make sure I put the dx in the other integral there. Okay, so for the first one, I'm going to be able to use substitution. And I know that I can integrate this. This is going to become 16 over pi sine of 1/4 pi x minus, and I'm just going to go ahead and already integrate these sections, 2x cubed over 3 minus 3x squared plus 4x. And this is all from 0 to 2. Okay. I'm going to try to plug in, and I'm going to apply the fundamental theorem of calculus, plug in the 2, and then plug in the 0. And this is going to simplify to 16 over pi minus 16 thirds minus 12 plus 8. Let's see, I have 16 pi minus 16 thirds, and this is going to be minus 4. 16 pi minus, it looks like this is going to be 4 thirds. And I can just leave it like this. I'm not even going to worry about the pi. We don't have a calculator, so we're not going to simplify. Okay. Let's go ahead and go to part B. Part B is asking us to find the solid of the region R that's generated about the line y is equal to 4. So let me go ahead and draw that line, y is equal to 4. And as I'm drawing this, try to think about whether we're going to use disk method or washer method. And I think it's safe to say that we're going to use washer method because we have that empty space between the actual region or the line that we're revolving and the region itself. So we have lowercase or uppercase r in this case that we need to find, and lowercase r. So let's go ahead and do that now. Thankfully, we don't have to actually evaluate this, but we're just going to write it out. So remember, this is pi from a to b of uppercase r squared minus lowercase r squared dx. We already know our parameters just from 0 to 2. So pi, integral from 0 to 2. And this is going to be 4 minus the bottom function, which in this case is f of x, 2x squared minus 6x plus 4. Don't forget these parentheses and squared minus lowercase r, 4 minus 4 cosine of 1/4 pi x squared dx. And thankfully for us, we don't have to simplify. We don't have to evaluate this, so we are good. So the points that we're going to get here is if we write this correctly, obviously with our parentheses and making sure everything is squared, and you're going to get points if you put the right correct limits in this case. 0 to 2, just write them out and we're good to go. Okay. Now let's go ahead and go to part C. Part C, no surprise. These types of questions, they always ask you either the area and then the volume, and usually the last problem is going to be for you to find the volume of this region with a cross section. Now this cross section, if we read the problem carefully, they're already asking us that this is going to be our cross section. So it's the same region as part A. The only difference is we're going to use this equation, volume from A to B of the area of the specific cross section. Now the area that they specified was a square, so we know that we're going to use side square. Now how do we know it was a square? They specifically say here that the cross section perpendicular to the x-axis is going to be a square. So that means that our area, or our volume in this case, is going to be from 0 to 2 of side squared. Now, a lot of people are going to think that we're done here, but we're not, because remember, the side in this case is going to be the solid r. So it's going to be the distance from the top function minus the bottom function. So it's just like problem A. The only difference was that we had to use the actual area of this cross section, which was the square. And so now we're going to go ahead and do the top 4 minus, or 4 cosine 1/4 pi x minus the bottom 2x squared minus 6x plus 4. And then the whole thing is going to be squared dx. And it looks like in this case, write but do not evaluate. So we are good. We don't have to worry about anything else, but leaving that as our answer. Okay, let's go to the next problem. I like introducing this problem. I know it's a lot to read. So go ahead and take a second to see what's going on here. You can pause the video if you like, so you can see what the problem is about. But for the most part here, they're talking about the rate at which people enter a specific park after opening and the rate at which people leave the park. Now, it's important to know as we're reading this, that this is from 9 to 23. So from 9 a.m. to it looks like 11 p.m. So just keep that in mind. So if we start focusing on part A, all they're asking for in this case is for you to find the amount of people that entered the park by 5 p.m. So that's t equals 17. The amount of people that enter the park. Well, we know the rate of the amount of people entering the park. So the total amount of people that have entered the park is going to be the integral from 9 to 17. Now notice that I started from 9 because that's when it opened, to 17, that's 5 p.m. So all I'm really doing is I'm taking the integral of this specific function. Typically, these problems are going to be calculator problems. I mean, look at the equation for E. It is way too difficult for us to integrate. So we plug this into our calculator and we get about 6,004 people. enter the park. That's it. Okay, easy question for part A. They're just wanting you to know how many people enter the park by 5 p.m. Again, this is the amount of people entering, so we have to take the integral of the rate at which people enter. I'm going to leave that there. I'm not going to erase it because let's talk about part B. Part B, if you like, go ahead and pause it. But they talk about the price of admission. So it's $15 up until 5 p.m. and then $11 after 5 p.m., obviously, to close. So they want to know the total amount that we're going to make or this amusement park is going to make. So what we're going to do is we're going to take the $15 and multiply that by the amount of people that entered the park. If you notice, this is actually the value that we found in part A, plus $11, and then we're going to do 17 to 23 because that's from 5 p.m. up until closing time. And it's the same equation EFT. If we use our calculator, we're going to do 15 times 6,004 plus 11, and that second integral is about 1,271. Okay, if we use our calculator, we are going to get that the amusement park made a profit of, a profit of $104,041. Awesome. Okay. So I wanted to choose this problem because, again, this is a situation where they talk about the amount of things, or in this case, it's people, but it could be the amount of water, the amount of the population, the amount of bacteria that enter or are present. And then they start talking about something where this is the amount that people are leaving, the amount of bacteria that is being picked up, or the amount of trash, the amount of water, whatever it might be. But you always have an equation that's entering and then an equation that's leaving. And this is where part C comes around. They want us to interpret what H of T represents. Now look at H of T in this case. H of T is this weird equation, the integral from A to B of E of T minus L of X. So H of T just represents the total amount of people because you have the amount of people entering minus the amount of people leaving. So H of 17 in this case is just going to represent the amount of people present at time equals 17, so 5 p.m. It's the amount of people present. That's it. Now, be very careful because sometimes, and I would say almost a lot of times, if this type of problem showed up, they talk about the original amount. So sometimes they'll say that, when the park opened, there were 100 people. Let's just say that's an instance because that could technically happen. So then H of T, and if they were to ask you to write the equation, then you will have H of T is equal to the integral from from A to B of E minus L, which is the amount of people entering minus the amount of people leaving. And then you're going to have to put a plus 100. That's if they talk about an initial amount of people before we even open the park. So we just have to make sure we write that. Now, usually they're going to give you an initial amount only when they want you to write the equation that represents the amount of people in a park. So if they wanted you to write this H of T, keep that in mind. That second part in part C is they want you to interpret H prime of 17. Well, H represents the amount of people present. And in this case, H of 17 is the amount of people present at time equals 5 or at 5 p.m. So H prime is going to represent the rate at which the rate of the amount of people that we have at the park. Now, they want us to find these values. So H of 17, if we use our calculator, is going to be the integral from 0 to 17 of E of T minus L of X. We could easily find that. But what they're going to want us to find, or what they want us to interpret, is H prime of 17. Now, what they want us to find here is they want us to use the second fundamental theorem of calculus, and H prime of t is just going to represent E of t minus L of t. So then h prime of 17 is equal to h of 17 minus L of 17. We're going to use our calculator to plug those values in, and we get that this is negative 380.281. So this is the rate at which people are in the park. Now, if you notice, this is a negative value. So if they want us to interpret this, this means that the rate at which people enter the park is decreasing, and that's exactly what you're going to write. So rate of people in the park is decreasing. And that's exactly what you're going to have to write. Okay, now part D, pretty simple question. They want us to find whether there's going to be a maximum amount of people at the park. Well, that's where we're going to have to take h prime of t and set that equal to 0, meaning we're going to find the critical point. Now keep in mind, h prime of t is the same thing as E of t minus L of t. And if we're setting that equal to 0, we can bring the L function to the other side. So really all we're trying to find is when does the rate at which people enter the park and leave the park the same amount. And if we plug that into our calculator by graphing it or using the solve function, we're going to get 15.794. And that's going to be the time at which the amount of people at the park is going to be a maximum. All right, let's go to the next question. Go ahead and pause it so you can read it if you like. Take a look at it, process it, digest these types of problems, and just see how we can even start attempting part A. I'll give you a quick second to take a look at it. So part A is a little weird because they're asking that we're going to determine whether or not this f is concave down. Now, out on the right, this function is f prime. And they want us to find whether it's concave down from 1.7 to 1.9. Looking at the graph, it's about maybe here to here. It's what kind of I've colored in blue. Actually, it might even be less than that. It might be like from here to maybe here. Now let's interpret that really quickly. The derivative is negative, but because we're talking about concavity, we're really trying to examine f double prime. So f double prime is the slope of this particular function. Again, f double prime is the slope of f prime. Because we have the graph of f prime, we can see right away that the slope here is negative. So that means that because the slope of f prime is negative, that means that f double prime is going to be negative. So that means that it's going to be concave down. So the types of points that they're looking for, or the reasoning is, you have to say because the slope of f prime, and maybe in parentheses, which is the second derivative, is negative, that means that the second derivative is going to be concave down. So for part A, f double prime is negative, so it is concave down. Okay, let's go to part B. So part B, we're trying to find the value of x at which f has an absolute max. Now, how do we find these things? Well, the first thing that we need to find is we need to find the critical points. So we need to find where f prime of x is equal to 0. Luckily for us, we have the graph, which is here and here. Okay. And of course, we have to test our endpoints because they're talking about from 0 to 3. So we know that we're going to have to test f of 0, f of 3. We're going to have to test this f of, we don't know what it is, that first value. We actually might need to find that. And then, of course, we need to test the other point. Now, I'm just going to call these like x1s and x2. So we got to figure where those values are. Okay, so that's going to be the first step. So the very first step is we need to find where the derivative is equal to 0. Luckily for us, we have the equation that's given to us on top. They give us that f prime is equal to that e to the power of negative x over 4 times sine x squared. So we're going to go ahead and we're going to set this equation equal to 0. Okay, so the idea, because we have two things we multiply together that equal to 0, we need to set both equations equal to 0. Now, that e of x, that never equals 0. That's always positive. So we are not going to find any value of x that makes that equal to 0. But the next one we will. Now, the terms or the types of values that we have here, the inside has to be 0. It has to be pi. It has to be 2 pi. And it has to be 3 pi. And so on and so on. So if I take the square root of both sides, I get that 0, or x is equal to 0, root pi, root 2 pi, and root 3 pi, and so on and so on. Okay. Well, the first value, x is equal to 0, we already know, we already have that as our critical point, so we're good. So the next value is root pi. That looks like that's going to be our x1. So we know that x1 is going to be root pi, and it looks like we have the next value is going to be root 2 pi. And I think that's it. That's all we need on the graph. If we use root 3 pi, I believe that's going to be a little further. We don't need that anymore. It's not going to be within our parameters. So let's go ahead and check this out. Up on the graph, we have root pi as x1 and root 2 pi as our x2. We can already eliminate root 2 pi. Because you're talking about a maximum here, root 2 pi is going to be a minimum because the derivative is negative and then it's positive. So that means that technically this is going to be a minimum. So we don't really have to use that one. So the only values that we really need to check are f of 0, f of 3, and f of root pi. So let's go ahead and do that. Let me go ahead and erase some values. Now, the unfortunate part is that we only have the f prime. So we need to find f of x. Now, they gave us a specific condition. They said that f of 0 is equal to 5. So the way we're going to find all these values is f of 0 is already equal to 5. So we're good. I'm going to go ahead and put the 5 there on the right. We need to find f of 3. So the way we're going to do that is we're going to do the integral from 0 to 3 of f prime is equal to f of 3 minus f of 0. This is by the first fundamental theorem of calculus. So I have the integral of e to the negative x to the 4th sine of x squared dx is equal to f of 3 minus 5, because f of 0 was equal to 5, which is great. And so now, unfortunately, what I need to do is I need to add the 5 to the other side, and I need to find the integral that I have on the left side. So all I do is I plug it into my calculator, I add the 5, and I get that f of 3 is 5 point, whoops, it's in yellow. Let me go ahead and erase that. Or in blue, 5.57. Okay, so that's my f of 3, so 5.57. If I compare f of 0 and f of 3, it looks like f of 3 is winning to find as the absolute max. And the last one that I needed to calculate is f of root pi. So I'm going to take the integral from 0 to root pi, or f prime of x is equal to f of root pi minus f of 0. And again, I'm going to integrate the left side in a bit. On the right side, I get f of root pi minus 5, and I'm going to add the 5 to the other side once I integrate. And this is going to be 5.67. Let me go ahead and put that on my list there. And if I compare all three values, it looks like the maximum value is going to be at root pi. Okay, that was a tough one. And these problems, this is one of those problems that if you get it on the test, it's going to be the one that a lot of people talk about just because it's confusing and it could be annoying. Okay. Now let's go to part D. Or part C in this case. Wow. There's so many steps here that I thought there was a part D. So in part C is write the equation of the line tangent to the graph at x equals 2. Well, that's, again, line tangent to the graph. That's y minus y1 is equal to m times x minus x1. So we need to find our x1, our y1, and our slope. Let's talk about the slope first. The m is the same thing as the slope of the function at 2. So all I really need to do for that value is plug in my derivative value. I need to plug in 2 to that function. And that's going to be about negative 0.459. Just plug that into your calculator, into the derivative function, and you're good to go. Let's go to x of 1. We know that that's going to be 2. The challenge here is to know your y1. They're not going to make it that easy for us. Y1 is the same value as f of 2. So we need to figure what that is. So that's where we're going to use that same idea as part B and do the integral from 0 to 2 of f prime of x is equal to f of 2 minus f of 0. And again, this is just the integral of that derivative function, and that's equal to f of 2 minus 5. Once I integrate, I plug everything into my calculator for the value on the left side. I add the 5, and I get that f of 2 is about 5.623. And so now I find that my y1 is 5.623. And once I've done that, smooth sailing. Y minus 5.623 is equal to negative 0.459 times x minus 2. And they don't want anything else from us. We are good. This is where we leave it. Okay, cool. Let's go ahead and move forward to the next problem. Go ahead and take a look at that again. Pause the video if you need to. And hopefully you could all recognize this, because this is just slope fields. And part A, I think it's always the easiest one. And if you notice in part A, they specifically say that use the areas provided in the pink test booklet. So that means that they're going to give you where to draw this, and if your response, they're going to have the graph there for you. So all you really have to do is look at every specific point and find what the slope is at that point. So for example, I'm just going to choose, I'm going to choose 1, 2. That's up on top. So when x is equal to 1, y is equal to 2, my derivative is negative 2 times 1 over 2. So this is negative 1. So all I have to do is go to that point and graph a good estimate of what a slope of negative 1 will look like. And you do this for every single point that is on the graph there. So it looks like I see 12 different points. Shouldn't be too bad. Okay, you can go ahead and pause the video if you like and complete that. And then we're going to go ahead and move on to part B. So part B is asking you to find the particular solution with the initial equation f of 1 equals -1, but they want us to write the equation of the line tangent to the graph. the equation of the line tangent to the graph. That's y minus y1 equals m times x minus x1. Well, they give us a specific point already, 1 comma negative 1. So that's going to be y minus 1 is equal to m times x minus 1. And I apologize, it's going to be 1 y plus 1 because it's y minus negative 1. And in our last step here is to find the value of the slope, the m. That's just plugging in 1 comma negative 1 into my derivative. And that's going to be 2 times 1, or negative 2 times 1 over negative 1. And that's just 2. So I go ahead and plug that in, and I get 2 times x minus 1. And the last step, we're not going to be finished yet because now they just want us to approximate f of 1.1. So that's just plugging in 1.1 into your x. So you get 1.1, or y plus 1 is equal to 2 times 1.1 minus 1. And I believe this is a non-calculator portion, but we can easily work this out. This is going to be y plus 1 is equal to 2 times 0.1. So y plus 1 is equal to 0.2. Subtract the 1 to the other side, and we get y is equal to negative 0.8. And that is our estimate of f of 1.1. That's it. So as you can already tell, part A and part B are really simple, as long as we're aware of the types of problems that they're going to give us. So now let's go to part C. So they want the particular solution at the initial condition f of 1 equals negative 1. That's just a matter of taking my function and using separation of variables to integrate this. So I'm going to go ahead and bring the y to the other side. So I get y dy dx is equal to negative 2x, and then bring the dx to the other side. Y dy is equal to negative 2x dx. And at this point, I just integrate both sides. So the first one is y squared over 2 on the left side, and then I have negative x squared plus c. I need to eliminate, or in this case, I can go ahead and plug in my initial condition, 1 comma negative 1, and I'll get negative 1 squared over 2 is equal to negative 1 squared plus 1, or plus c. So that means I have negative 1/2, or positive 1/2 equals negative 1 plus c. Okay, and I'm gonna subtract or add the 1 to both sides, and I get 3/2 is equal to c. And so now I can plug that in into my equation that I had, but I still need to solve for y. So I need to multiply the 2 to the other side, get y squared is equal to negative 2x squared plus 3. And then at the very end, I'm going to go ahead and take the square root, and I get the square root of negative 2x squared plus 3. And that is my particular solution with the given initial condition. This is one of the easier problems that you can encounter on the exam. Slope field, write your slope field, usually they want you to find an approximation, just like part B, and then part C is not a surprise. They want you to find the particular solution given the initial condition. All right, let's go ahead and move on to the next problem. And that is related rates. Another common question that I see pop up on the AP exam. So go ahead and pause the video if you'd like. Look at it, see if we can write out part A and see if we know how to approach it. Okay, so in this particular solution, oh my goodness, got something stuck in my throat there, I'm sorry. So in this particular solution, they mentioned that the volume the rate of change of the volume is negative 5 pi root h. So we can already say that dv dt is equal to negative 5 pi root h. And luckily for us, they give us the equation for volume, which is pi r squared h. If we don't remember it, that's a good thing to have. Okay, so for part A, they want us to show that this is in fact, that dh is equal to, dh over dt is equal to negative root h over 5. Okay, well, let's go ahead and start off by writing that our equation volume is equal to pi r squared h. This is a cylinder. If you notice, or just think about, if we were to fill this up with water, the radius will never change. It will always stay the same. It's always going to be 5. So I can already say that this is going to be equal to the volume 25 pi h. And this is where I use integration or related rates. I'm going to take the derivative, and this is going to become 25 pi dh dt. dh dt is what we're trying to find. I already know that dv dt is equal to that negative 5 pi root h. So I plug that in. And then let's go ahead and divide the 25 pi to both sides. And I get negative root h over 5 is equal to dh dt. And that's exactly what they wanted us to find in part A. So very simple. They just wanted us to create the equation and identify that the radius never changes. So we are good. We're going to leave it just like that. Okay, part B is interesting because they're giving you an initial condition that when t is equal to 0, the height is 17. So solve the differential equation and write it as a function of h in terms, or write it as a function of h of t. So I'm going to go ahead and write the value that we got from part A. I'm using separation of variables. Let's move the dt to the other side. dh is equal to negative root h over 5 dt. And I'm going to have to divide the root h to the other side. So dh over root h is equal to negative 1/5 dt. This is where I have to integrate. And before I integrate, I'm going to move the root h to the top, and I'm going to turn it as h to the negative 1/2. dh is equal to negative 1/2 dt. All right, this is where I go ahead and integrate. The top value, or the value on the left side, becomes h of 1/2 divided by 1/2 is equal to negative 1/5 t plus c. Let me just rewrite these things. I can bring the 2 to the top. The h to the 1/2 becomes a root h, and negative 1/5 t plus c. This is where I use the initial condition that when t is equal to 0, h is equal to 17. So I get 2 root 17 equals 1/5 times 0 plus c. So right now I know that my equation is 2 root, or that my c value is 2 root 17. So now I have my equation. 2 root h is equal to 1/5, negative 1/5 t plus 2 root 17. Bear with me. I know these are very close to the margins, but hopefully you can read it. I'm going to divide everything by 2. So root h is equal to negative 1/10 t plus root 17. And then I'm just going to take the square of both sides. So my h is equal to this negative 1/10 t plus root 17 squared. And that's it. Now for part C, before I erase this, or just go ahead and look at it, they are asking to find the value of t when the coffee pot is empty. Well, that means that my height is going to equal to 0. So I'm going to use the equation that I found for part B, which is obviously important to make sure we get correct in the beginning. And I'm going to set that equal to 0. So let me just erase my values. Hopefully you have the answer for part B written out. And we have 0 equals negative 1/10 t plus root 17 squared. Okay. Don't worry if I'm writing too fast. This is the beauty of this video. You can always pause it right when you want, work it out, rewind if you need to, and I'll be waiting here for you. So we're trying to solve for the value of t when this is equal to 0. I can take the square root of both sides. 0 is equal to negative 1/10 t plus root 17. I can move the 17 to the other side. Is equal to negative 1 over 10 t. Multiply the 10 or the negative 10 to both sides to get 10 root 17 is equal to t. So at this many seconds is when the coffee pot is going to be empty. All right. Let's move forward to the next problem. Go ahead and again pause this video. Hopefully you recognize these types of problems that constantly show up in class or on the AP exam. This is just equations where you need to find the area underneath the curve. So for part A, they want us to find g of 2 and g of negative 2. Well, g of 2, if we use the equation on top for what g of x represents, is the integral from 1 to 2 of f of t. Now we're given the function of f up on top. So the integral represents the area underneath the curve from 1 to 2. So that means that we need to find this little area. Hopefully you can see that I wrote it there. Technically, the area of that small triangle is 1/4. Again, because the area is equal to 1/2 the base, which is 1, times the height, which is 1/2. So 1/4. But remember, this is a negative area. So then this area for g of 2 is going to be negative 1/4. And then g of negative 2 is the area from 1 to negative 2. Look at that direction. We start at 1 and then go to a negative 2. So up on the graph, I'm going to go ahead and do from 1 to negative 2. So we're trying to find the area, but we're going in the negative direction. So technically, the area that's negative, which in this case is a semicircle, is now going to be a positive area. And the area that looks positive, which is the triangle, is now going to be a negative area. So if you look at those values, this is going to become pi over 2 minus 3/2. It's just the area of a half circle and the area of a triangle. All right, so part B. Find g prime of negative 3 and then g double prime of negative 3. This is where we have to really just start getting used to what this means in terms of f. Now, g prime of negative 3, before we even do that, let's go ahead and observe. We know that g of x is equal to 1 of x, of the integral from 1 of x of f of t dt. So g prime is just going to be f of x. This is by the second fundamental theorem of calculus. We just take the integral, or we take the derivative of this integral, and we get that g prime is equal to f. So back to the problems that I had in part B, g prime of negative 3 is really just f of 3. And we can look at the function f of 3, and it's going to be equal to 2. We just look at the graph there and find that the y value when x is equal to 3, x is equal to negative 3, is going to be 2. And so g prime of negative 3, or g double prime, since g prime is f, g double prime will be f prime of negative 3. So on the graph, that means that we're looking for the slope at negative 3. Now the slope at negative 3 is just the slope of that line, which is a linear equation. So they give you easy functions. So all you have to really do is just look at the slope of that, and you're going to find that you go up 2 units over 2 units, so the slope is going to be 1. So g double prime of negative 3 is going to be 1. let's go ahead and talk about part C. Again, go ahead and pause that if you need to. But we need to find the x-coordinate where the graph of G has a horizontal tangent line. That's the first part. Let's just go ahead and find that. X-coordinates where G has a horizontal tangent line. Horizontal tangent line means when the derivative of this function is equal to 0. So when is G prime equal to 0? If we learn anything from part B, we know that G prime is the same thing as f of x. So when is f of x equal to 0? So all we really have to do is look at our graph, and you can tell that f of x is equal to 0 at x is equal to -1 and 1, because that's when the graph has x-intercepts. And now they want for each of these points, which is -1 and 1, to determine whether it's going to be a relative minimum, a relative maximum, neither. We'll have to figure that out. So let's just go ahead and draw the little number line, because technically these are the critical points for G. So we have to look at, or we have to observe what happens to the derivative of G to the left of -1. So let's just say I plugged in a point, because that's how we test these things. Let's just say I plugged in x is equal to -2. So really what I'm looking for is what is G prime of -2, aka what is f of -2? And that's positive. So now we know that the function is increasing for G. If I pick a point in between, x is equal to 0, I'm looking for G prime of 0, aka f of 0. And if you notice, that's also going to be, or that's negative. And then to the right, I'm going to plug in 2. I'm looking for G prime of 2, which is the same thing as f of 2. And on the graph, this is negative. So it looks like G is increasing, decreasing, and then just continues to decrease again. So the only value that has a relative extrema, a relative minimum, a relative maximum, is going to be at -1. So we know that at x is equal to -1, G has a max. And of course, we have to justify. We have to say because it's changing from positive to negative. And at x equals 1, G has neither. Why? Because it was decreasing and then decreasing again. Okay, that was part C. If you understand the difference, or like how G relates to F, I feel like these problems are going to be pretty easy for you. So for part D, they want to find all the values of x for which the function has a point of inflection. Well, point of inflection, what is that? It's when the second derivative changes direction. So we need to find, where does G double prime of x equal to 0? In other words, when does f prime of x is equal to 0? So we need to find when the function has, or when the slope of f, so the slope on the graph, has a slope of 0. And it looks, looking at the graph, it's at -2, and then here at 0, and then at 1. Again, because that's when the slope of the function of f has a slope of 0, meaning that that's when G double prime of x is going to equal to 0. So where does it have a point of inflection? Well, let's see. Let's look at the graph. The slope goes from positive to negative. It's changing direction, so we can say that is a point of inflection. So bingo, that works. And let's see, it has a slope of, it's still negative, and then when we get to 0, it changes direction, it goes positive, and then it goes negative. So a point of inflection only occurs when the second derivative, in this case the first derivative of f, changes direction. So it went from positive to negative to positive to negative. So we can say that these points have point of inflections at every single value that we found: -2, 0, and 1. And that's how we're going to write it. We're going to say something along the lines of, because G prime of x which is equal to f of x, changes direction at x is equal to -2, 0, and 1. G has a point of inflection. I'm just going to put POI at x equals -2, 0, and 1. So as long as I think you write that, you should be good. All right, let's go to the next problem. We got 3 more to go, it looks like. Okay, go ahead and pause that video if you like again. I said 3 more, but I think there's 4 more. But anyway, I digress. Okay, go ahead and pause the video, see if you can solve part A. They give us that weird derivative, or they give us the weird function and they want us to show that the derivative is equal to that value. So how can we go ahead and solve it? I mean, we're just going to use implicit differentiation. So for part A, I'm going to go ahead and start taking the equation that they give us up on top, and I'm just going to go ahead and differentiate that. So that becomes 6y squared dy dx, because that's how we use integration or implicit differentiation, plus 12xy, I'm using the product rule here, plus 6x squared dy dx, minus 24x plus 6 dy dx is equal to 0. Okay. Lots of things here, that's for sure. So I'm going to go ahead and move the values that don't have any dy dx's. In this case, it's only 2 of the terms. I highlighted them, underlined them in blue. I'm going to move that to the other side. So I have 6y squared dy dx plus 6x squared dy dx plus 6 dy dx is equal to -12xy plus 24x. And then I'm going to go ahead and factor out the dy from both sides. And I get 6y squared plus 6x squared plus 6 is equal to -12xy plus 24x. And I'm just going to divide everything to the other side. Dy dx is equal to -12xy plus 24x all over 6y squared plus 6x squared plus 6. Okay. This doesn't look like the answer that they want us to write, but it's very close to it. So I think the last thing that they want you to do is they want you to divide everything by 6. And the reason why I'm saying that is because in the answer for part A, they wanted us to show that the bottom has just x squared, y squared, and 1. So that just means that the 6 has to go away. So when I do that, that's going to be dy over dx equals -2xy plus 4x all over y squared plus x squared plus 1. Okay. Now, if I rearrange the things on top, so the 4x is in the front, and then if I rearrange the bottom, so the x squared is in front, it's going to be the same value. Perfect. So we just applied implicit differentiation, and we are good. Okay, so let's go ahead and go to part B. So part B, write an equation of each horizontal tangent line. Horizontal tangent line, that's going to occur when dy dx is equal to 0. So really all we're trying to find is when is 4x minus 2xy over x squared plus y squared plus 1 is equal to 0. Well, we don't want the bottom to equal to 0 because that will make it undefined. All we care about is we want the top to equal to 0. So we want 4x minus 2xy to equal to 0. And the trick here is to make sure that we kind of like mess around with the values and figure out which ones are going to give us that equal to 0, this equation equal to 0. So I'm just going to go ahead and factor out a 2x. So I have 2 minus y in the parentheses is equal to 0. And we know when this occurs when x is equal to 0 and y is equal to 2. So these are 2 different scenarios. So we have x is equal to 0, y is equal to 2. When x is equal to 0, we're going to plug that in to the original equation, and that's going to be 2y cubed plus 6 times 0 squared y minus 12, 0 squared plus 6 times y is equal to 1. So if I simplify this, this becomes 2y cubed plus 6y is equal to 1. And this is probably a calculator portion. So we're going to have to use our calculator to find out what the y value is where this is equal to 1. And that is y is equal to 0.165. So now we have our equation. Y is equal to 0.165. Now the other equation is going to be y is equal to 2. Plug in 2 into this equation. We're going to get 2 times 2 cubed plus 6x squared times 2 minus 12x squared plus 6 times 2 is equal to 1. And that's going to be 16 plus 12x to 24, or 12x squared minus 12x squared plus 12 is equal to 1. Check that out. 12x squared minus 12x squared cancels out. And we get 16 plus 12 is equal to 1. And that can happen. So right away, we just get an error. So the only horizontal tangent line that we should have is going to be y equals 0.165. And that is part B. Now let's go to part C. They have the line that's crossing through the origin with a slope of -1 and is tangent to the curve at a point P. So we need to find the x and the y coordinate for point P. So if it's going through the origin for part C, we already know that this line is going to be y minus 0 is equal to -1 times x minus 0. If we simplify that, that's just y is equal to -x. So we're going to go ahead and plug in -x in for our y's in the original function. So we're going to have 2 -x cubed plus 6x squared times -y minus 12 times, I said -y, -x, minus 12 times x squared plus 6 times -y. I keep saying -y, but I mean -x is equal to 1. So this becomes -2x cubed minus 6x cubed minus 12x squared minus 6x is equal to, and that's going to equal to 0. Equal to 1. So I'm going to bring the 1 to the other side, -2x cubed minus 6x cubed minus 12x squared minus 6x is equal to -1. Let's see, can I combine anything? Yes. The x cubed, so -8x cubed minus 12x squared minus 6x, whoops, minus 1 is equal to 0. And if we were to graph this, we would get that x is equal to -1/2. And we will find that the y value for that specific coordinate is also going to be 1/2. A few more problems to go. Let's go to the next one. Go ahead and pause that problem if you need to so that we can go over it. Let's try to see and figure out how we will solve this. So for part A, they're asking for when the particle is moving to the right. When the particle is moving to the right, that's another way of saying when is the velocity greater than 0. Now we're focused on particle r, so we're going to find when is r prime of t greater than 0. So let's go ahead and take our derivative, which is 3t squared minus 12t plus 9. We can factor out a 3 and get t squared minus 4t plus 3. And this becomes 3 times t minus 3, t minus 1. So we have a couple of values. T is equal to 1 and T is equal to 3. So up on top, I'm going to put my number line up on here, 1 and 3. And if I test points in between, let's just say T is equal to 0, T is equal to 2, and T is equal to 4, then I'm going to find that when I plug in 0, it looks like it's going to be positive, then negative, and then positive. Now for part A that we're asking for, when is a particle moving to the right? It is moving between 0 and 1. And the reason why I did 0 and 1, because in the very beginning they talk about this is only defined from 0 to 6. So between 0 and 1, and we're going to say between 3 and 6. That is part A. I'm going to erase this. And now let's go ahead and look at part B. So we want to find out when both particles are moving in the opposite direction. Well, we already know the directions for particle R, so we're going to go ahead and look at particle T. So I'm going to go ahead and take the derivative of this, and it's going to become -2 sine of pi over 4t times pi over 4 if I apply the chain rule. So this becomes negative pi over 2 sine of pi over 4t. So all I really need to find out is when is sine equal to 0. And that's going to happen at a couple times. T is equal to 0, and it looks like T is equal to 4. Because when T is equal to 0, that's going to be sine of 0, which is 0. And when T is equal to 4, that's going to be sine of pi over 4 times 4, which is the same thing as sine of pi, which is equal to 0. And so I'm going to go ahead and test points in between. I have between 0 and 4. Now, we don't really care for what's on the left of 0 because it's not defined there. So whether it's moving to the right or left, it's not going to matter because it's the function is only defined between 0 and 6. Because that was given to us in the very beginning. So we're just going to plug in some points in between. So let's just say I plugged in like T is equal to 1, and I get that this is negative, and T is equal to 5, and that is going to be positive. So if I kind of line this up with my other value, so this was 0, 1, this is R of T, and the top was P of T. I have 3, so negative and positive. When is it moving in the opposite direction? Well, it looks like between 0 and 1, they have opposite values. One is moving to the left, the other one's moving to the right. In between 1 and 3, it looks like they're both negative, so that's fine. And then from 3 to 4, it looks like one is negative, one is positive. So that means that they are moving in opposite directions from 0 to 1, and then from 3 to 4. All right. So they want us to find the acceleration of the particle P. So for part C, the acceleration is just asking for the second derivative of the function. Now, we knew that the first derivative, let me just simplify this. I got negative pi over 2 sine of pi over 4t. So then my second derivative is just going to be negative pi over 2 cosine of pi over 4t times pi over 4. Let me just simplify this. Negative pi squared over 8 cosine of pi over 4t. And they want us to find the acceleration at t is equal to 3. So I'm trying to find the second derivative at 3. And that's negative pi over 2 pi squared over 8 cosine of 3 pi over 4, which looks like it's negative pi squared over 8 times negative root 2 over 2, which is going to be positive root 2 pi squared over 16. Some weird value. We found it. That's all they want us to find. And now the last step is they're asking, is it speeding up or slowing down? Well, it's speeding up if the derivative and the second derivative are the same sign, and it's slowing down if the derivative and the second derivative are both opposite signs. So we know that the second derivative, the acceleration, is going to be positive. So we need to just compare that to the first derivative. So again, that's plugging in -pi/2 sine of, and then I'm going to go ahead and plug in the value of 3 for my time. And that looks like it's going to be -pi/2 times √2/2. So that's negative. So we have the acceleration is positive, the velocity is negative. So that means that it is going to be slowing down at time equals 3. And this is the explanation that we have to show. Because the acceleration is one value, the velocity is another value, that means that it is going to be slowing down. All right, part D. Write but do not evaluate the expression of the average distance. Average distance reminds me very much of average value. So we're trying to find something like this. They told us that it's between 1 and 3. So our average distance is going to be 1 over 3 minus 1, integral of 1 to 3. And this is just average distance. So I'm just going to take the distance between P of t minus R of t. Now, I don't know which one's in front, which one is further away from each other. So this is why I'm going to take the absolute value, because it's just going to give me the distance. Whether it's a positive or negative distance, taking the absolute value will give me the distance between the two particles. And they don't want us to evaluate this, so we're good. This is where we leave it. This is where we finish it off. Maybe we simplify and do 1/2 integral from 1 to 3 of particle t minus particle r dt. And we're done. I think this was a lot easier than possibly part A, B, and C. All right. Almost done. I believe we got 2 more problems. Give me 1 second. Looks like my mouse died. I am fixing that. I'm going to go ahead and scroll down to the next problem. Here we go. So again, go ahead and pause that video if you need to. Read it out. See if you can solve part A. So they want the equation of the line tangent to the graph of f at x equals e squared. Well, we already know that we have to use y minus y1 is equal to m times x minus x1. We know our x1 is e squared. I'm just going to find y1. Luckily for us, they give us f of x, which is really nice. So this is going to be f of e squared, which is ln of e squared over e squared. So just 2 over e squared. It's really nice. And now we just have to find the slope at that point. Well, again, they give us f prime. It's too good to be true. I feel like there's going to be something with this problem. It's going to make it a little more difficult. So we'll figure that out in a second. So this is going to be 1 minus 2 over e to the 4th. So just -1 over e to the 4th. So our equation is going to be 1, or y minus 2 over e squared is equal to -1 over e to the 4th times x minus e squared. Looks funky, but that's all they want. Okay, so fine, we need for part B, we need to find the x coordinate of the critical point. So that means for part B, we need to find when f prime of x is equal to 0. In other words, 1 minus ln of x over x squared is equal to 0. We don't want the bottom to equal to 0. We know that that's going to be a function that is undefined. So we're going to make the top equal to 0. 1 minus ln of x is equal to 0. So 1 is equal to natural log of x. And that occurs when x is equal to e. That's the only point where you're going to have some sort of critical point. Now, just be careful. Technically, you also have a critical point at x equals 0 because that makes the function undefined. However, the top ln of 0 is not defined. the natural log is not defined at x is equal to 0. So that means that we can't even use x is equal to 0 as a critical point, so to speak. So we're not even going to test it. All we're really going to worry about is e. So we're just going to test some points. So maybe x is equal to 1. Actually, let's do x is equal to x is equal to, gosh, what should we do? Like x is equal to like 1.5 and then x is equal to 3, just to get an idea. And I'm testing these. So f prime at 1.5 and f prime at 3. If I plug these into my derivative, it looks like it is positive and then negative. So that means that my function is going to be increasing and then decreasing. So because the function changes from positive to negative, or the derivative changes from positive to negative, x, or the function of f, is going to have a maximum at x is equal to e. So that's how we need to justify f prime changes direction, or changes from positive to negative. F has a max at x equals e. Okay. Let me go ahead and let's go to part C. They're talking about the graph of f has exactly 1 point of inflection. We need to find the coordinate of this point. So that's the second derivative. We already have the first derivative, thankfully. So all we really need to do is apply quotient rule into that f prime to find the second derivative. And let's see. That's going to be x squared times negative x minus 1 minus ln of x times 2x all over x squared squared. Okay, let's simplify this a little bit. It looks like I have negative x minus 2x plus 2x ln of x. So weird. All over x to the fourth, which becomes a negative 3x plus 2x ln of x all over x to the fourth. Well, all we're really doing here is making sure we set this equal to 0. So I can just set the top equal to 0. Factor out an x and have negative 3 plus 2 natural log of x is equal to 0. Now, technically, we can say that x is equal to 0 is one of the critical points, or the points of inflection, possible points of inflection in this case. But like we mentioned before, natural log is not defined at 0, so we can't even use that point. And at the very top, they tell us that our function is defined when x is greater than 0. So x can never equal to 0 in this case. So we're not even going to worry about that x that's in front of the parentheses. So all we really need to find is when is negative 3 plus 2 natural log of x equal to 0. That's going to be when 2 natural log of x is equal to 3, or natural log of x is equal to 3 halves. So x is equal to e to the 3 halves. And we technically need to test these points when it's changing direction. So we need to test e to the 3 halves for when it's changing direction there. So really you need to plug in, maybe like 1.5, x is equal to, let's do something like 5 just to make sure. And it changes direction. It goes from negative to positive. So it is changing, the point of inflection is changing direction. So we can say that this is going to be a point of inflection at e to the power of 3 halves. All right, so let's go ahead and go to part D. The limit as x approaches 0 from the right side of f of x. Well, luckily for us, we already have this function. So that's ln of x over x. Okay, so let's think about what's going on here. If we were to plug in something really close to 0 on the right side, natural log, let's just say we plugged in like 0.0001 from the right side and we have 0.0001 on the bottom. Okay. Now the bottom is really, really small, so it's going to make the top big, or our equation really big. Natural log of 0.001. If you remember how natural log looks, natural log kind of looks like this graph right here. Now, as it's approaching 0 from the right side, it looks like it's going to negative infinity. So we have a really negative big number over a small on the bottom. And that's just going to become an even greater, bigger number. So this is going to approach negative infinity. And that is part D. The best part here, I don't even think there's much explanation that you have to show. We just have to start thinking about what happens as we approach 0 from the right side. So meaning what happens is we plug in something really, really small from the right side, like natural log of 0.0001. So it's just a matter of you knowing how natural log works and how these fractions are going to affect this limit. Let's go to our final problem. Go ahead and pause the video if you need to. Take a break if you need to. And let's go ahead and finish it up. So they give us f of x and they want g of x, or they want f prime of x and they want g prime of x. So let's talk about f prime first. F prime, I'm just going to go ahead and use the second fundamental theorem, but be very careful because we had a 3x on the top. Let me zoom in. I think it's a little too small. There you go. It's much better. Okay, so I have a 3x on top. So I need to make sure that when I take this derivative, yes, I'm just going to plug in the 3x in for the t, but I'm also going to make sure that I multiply this by 3 because I'm applying chain rule. So this is 3 root 4 plus 9x squared. That is f prime, and in g prime, it's just equal to f prime of sine of x times the derivative of what's inside, which is cosine of x. So this is technically another form of chain rule. I believe we can leave it like this, but if you really wanted to, we know that f prime, if we want to simplify that f prime of sine x, we know f prime from the top equation. So this is going to be 3 root 4 plus 9 sine squared x times cosine. So in other words, 3 cosine x root 4 plus 9 sine squared x. All right. That is part A. And now for part B, they want write an equation of the line tangent to the graph of y is equal to g of x at x is equal to pi. Well, if you recall, let me just erase a couple things. But before I do that, I feel like we're gonna need these equations. So I'm just gonna write them down here. Luckily for you, you're gonna have them written down, but I have to make space for y'all. So 4 plus 9 sine squared x. So let me just erase these things now. And for part B, they want us to find the equation tangent to the graph of g of x. Nothing too difficult. So y minus y1 is equal to m times x minus x1. Okay, well, we know our x1 is pi. Our y1 is going to be g of pi. And if we think about that, that is f of sine of pi, because that's what was given to us for g in the very beginning. And we know that f is equal to that integral. But before we do that, sine of pi is equal to 0. So really what this is equal to the integral from 0 to 3 times 0 of 4 plus t squared dt. Take a look at that. This is the integral from 0 to 0 of root 4 plus t squared dt. So we know the integral from 0 to 0 is just 0. All that work just to find that our y1 is 0. And the last point that we need is we need m prime, or m, which is g prime of pi. Now we know g prime. Like I mentioned, I feel like we were going to use it, and we are, and that's going to be the g of x that I have on the top right. So that's going to be 3 cosine of pi root 4 plus 9 sine squared of pi. Let's simplify that. Cosine of pi is -1, so I have -3 on the outside, root 4 plus 9 sine of pi is 0, so that's kind of nice. So we're just left with 9 times 0. So we have -3 root 4, and root 4 is 2, so -3 times 2, which is equal to -6. So we have our slope, we have our x1, we have our y1. So at the very end, we're going to say that our equation is y minus 0 equals -6 times x minus pi. And that's really what they want. They want us to find that equation, and we have to do all that work so that we can give that one equation in point slope form. That's part C. Okay. And now the last part, a bit tricky, right? But you know how to evaluate an integral expression that represents the maximum value of g on the interval 0 to pi. Okay, well, if we want to find the maximum value of g, that's going to be when g prime of x is equal to 0. That's the first step. Let me go ahead and use red. G prime of x is equal to 0. Basically, we want 3 cosine of x root 4 plus 9 sine squared x equal to 0. So we have two scenarios. Cosine of x is equal to 0, or root 4 plus 9 sine squared x is equal to 0. Okay, let me focus very quickly on that root. That's going to mean that 4 plus 9 sine squared of x is equal to 0. But check this out. If I move the 4 to the other side and divide by 9, I get sine squared x is equal to -4/9. Sine squared x is going to be positive regardless, so there's no way that I can have a negative value. Another way to know that is if I took the square root of both sides, I get sine x is equal to root -4/9. That can't happen. It's an imaginary value. So I'm not even worried on that part. So what I want is all I'm focused on is cosine of x, and in between the intervals 0 to pi, the only time that this is equal to 0 is when x is equal to pi over 2. So that is going to be the maximum value. Now, this is when the maximum value occurs. I need to find the actual value. So really what I'm trying to find is I'm trying to find g of pi over 2, which if you recall from the very top, this is the same thing as f of sine of pi over 2. Now, sine of pi over 2, in this case, it's 1. So really what I'm looking for is I'm looking from the integral of 1 or 0 to 3 times 1 of 4 plus t squared dt. And luckily for us, they don't even want us to integrate this. They just want us to set it up. This right here is going to be the maximum value at x is equal to pi over 2. So a lot of like tricky scenarios here, but we just have to kind of start playing around with what does it mean when you have a maximum value? That's when g prime of x is equal to 0. You plug it in and you set your integral up. Luckily, we don't have to solve it. Now, it looks like I would get points for finding x is equal to pi over 2, finding my integral. But the one thing that they even mention is to justify your answer. And even then I totally forgot to come back. I just trust that at pi over 2, we're going to have a maximum, but we obviously have to test it. So I'm going to write this in blue down below. We have to test points to the left and to the right. So technically I can test like x is equal to 0 and x is equal to pi. And the derivative at x is equal to 0, it looks like it's going to be positive and it's going to be negative. So the function is increasing and then decreasing. And I've justified that that's going to be a max. So don't forget that part. I almost forgot it. Yes, I'm the one that's going over these problems with you, but even I make mistakes sometimes, and that's okay. All right, that does it for these 10 problems.
If you're feeling overwhelmed, that's okay, but I don't want you to put too much pressure on yourself. This is a difficult test and it's meant to challenge students. So my best advice to you is to practice as many multiple choice questions that you can find, as many FRQs, get plenty of rest the night before, and everything will figure itself out. All right, friend, this is where I leave you. I wish you the best of luck on the exam. Happy trails.